Yeah, I just want to get through this chapter. We can do it. We got time. So if we get through chapter 2, then your chapter 2 homework will be due Friday when you come and partake of the picnic after class. So if for some reason you're going to skip the class, at least turn in your homework, okay? So it's okay. No questions asked. You can always slip it under my door or something like that. Today's the 3rd. Yep. So we talked a lot about that hollow ball called the celestial sphere. You know, it kind of drives me nuts. It's kind of a neat idea. Okay, but here actually we're stepping out of the celestial sphere onto something a little bit more new, or a little bit more like I can believe that. I can really bite into that model. So you see the sun here. You see our planet orbiting the sun. What direction is the planet orbiting the sun? Counterclockwise. Yep. Okay. Now, do you recognize these constellations? If you're into astrology, you might recognize them. Okay, these are, if you're looking up your sign, okay, if you're into astrology, the sun passes through the constellation at the time of your birth, that time of year. So, for instance, I am a Sagittarius. Okay, so the sun passes through, okay, the sun appears to pass through Sagittarius in December. So, here, let me show you this. Discard. The way this works is we see the Earth orbiting the sun, and okay, so this is an animation your textbook put together. I'm going to have 2 views. See, in this view, we are on Earth looking towards the sun. Okay, and the Earth is going to orbit the sun. So can you see where the sun passes through, appears to pass through these background stars? Okay. I mentioned December, it's coming up. Okay, there's December. Okay, here we are orbiting the sun, and the stars are way far away from us. Okay, and they make these patterns, and it appears that the sun is passing through a group of stars called Sagittarius. Does that make sense? Now check this out. I'm going to stay in December, and I'm going to switch views. What stars do you think in December we're going to see at night? We are going to see these sets of stars dead in the middle of our night. Does that make sense? So now I'm going to go ahead and looking at the nighttime sky, go ahead, looking away from the sun, you can see that throughout the course of the year, as we orbit the sun, we are going to see different constellations. Let's see, let's get us to, we are starting, looks like it skipped from August to December. What? Look, it's like somebody put December instead of September. Isn't that, I didn't do this. That should be September. Do you guys see that? Okay, August, July, August, September, October, November, December. Typo. Okay. It's only because I wanted to go there because this is this time of year. So in September, we are privy to these stars at night, and we don't see these stars. Actually, the sun appears to go through these stars in the daytime sky. So I think it's a pretty good little animation. Okay. Did I skip a slide, or is this is okay, isn't it? Okay, good. So we see different sets of stars throughout the year. Okay. So now this is where I get a little slack. I shouldn't, but I do. So if your birthday is around, and mine is because I told you I'm a Sagittarius. If your birthday is in that time of year, notice that there is a 13th sign, okay, that that basically astronomers inserted, and astrologers, since it's so small, have just kind of ignored throughout the course of the time. So there is another, I know,
is that
sign
what
called
changed
Fucus.
everything?
I don't know. Do you follow astrology and stuff?
Yeah,
Okay.
that's why I was like.
How long
sorry.
ago did it change?
I don't know.
Okay.
That's why I looked at it and I was like, so I'm like 1 day off, but I'm still not
Yeah, my
Aquarius
boyfriend
anymore.
has a scorpion tattoo, but he's no longer a Scorpio.
Okay. See, I told you. Really? See, mine
he's
changed
got,
too.
he's got a huge piece of it on his arm and everything.
Don't tell him.
I'm totally telling him.
I'm
I'm totally
just so you know they
telling him.
changed it.
I think you can keep what you got, you know, because I think when you read the, almost said obituaries, when you read your horoscope, they don't have Ophiuchus there, do they?
I think they do.
What is
Do they
it?
now?
The days.
Yeah.
Some of them do.
Well,
Yeah, they
maybe
tell
we're in
you.
transition.
So when did this happen though? Like they just changed?
I mean, this has been, I don't know if your textbook addresses it, not, I think it's been a while. I don't think it's that new.
Is it because they added something so it like?
So I'm going to show you why it is. Okay, so case in point, where the sun is, okay, where the sun passes through is, oh, go back. Where the sun passes through, I'm trying to get my little drawer up here. Where the sun, you know, the background stars and the sun passes through, that's what gives you your sign, okay? So here we have the Ophiuchus. And before it was just kind of the legs of the Ophiuchus. I like the name Ophiuchus, but. So yeah, don't like freak out or anything, so. Okay. So one more slide about this. I think we're kind of all on the same track that as the Earth orbits the sun, okay, our nighttime skies, we're going to see different stars. Okay? So that's all good. Pretty boring if we didn't. Okay. I have a few slides. This is a very busy slide. I have a few slides on seasons. And one of the things about seasons, and I'll ask usually a straightforward question about seasons on your test, and then maybe more of a not so straightforward question about seasons. But if anybody asks you why the Earth has seasons as the Earth orbits the sun, my arm right here is the spigot that the Earth spins on, the Earth's axis of rotation. Because the Earth's axis of rotation is tilted, that's the reason we have seasons. Bottom line, tilted axis of rotation. Okay, so in here, I think we've done this before. If this is the Earth spigot, okay, so the Earth spins on this once every day, okay, and I bring this over here for the sun, and then what's the clock? Polaris. Polaris, very good. We should dub it Polaris. Okay, so here's the deal then, okay, the Earth's North Pole points to Polaris all the time. So actually, the way I have this configured, this is the sun. We think in summer or winter now for us in the northern hemisphere. How many people think summer? Yeah, me too. Okay, but it's not because it's literally closer. Okay, actually, it's because the tilt gives us longer days and gives us more direct sunlight. Okay, the deal here is actually if you are below one line of latitude called the Antarctic Circle, 66 1/3 degrees south latitude, if you're near the South Pole, here in the dead of summer, the Earth spins on its axis and you don't get any sunlight. Okay? So this would be, what, 6 months later? Okay, now we're at what season? We're in the winter, exactly. Polaris is over there, sun's here. Okay, again, there's a line of now in the northern hemisphere, there's a line of latitude, 66 1/2 degrees north latitude, that if you're a vampire, that's where you're going to migrate to, okay? Because the Earth is going to spin, and actually that line north towards the pole will be shadowed. Well, I won't say shadowed, but actually it's tilted so that it doesn't get any sunlight.
Isn't that also why, I think it's like in Alaska or something, or like once a year or something that the sun never sets?
Yeah,
It's like
there's
they
a,
see the sun.
there's a,
all day
exactly.
and all night.
Over here, that's the deal. And again, if you're above a certain latitude, north 66.5 degrees, when the Earth, as the Earth spins, the sun will never set.
Is there like an in-between where like all you see is sunset all day, like every day or something like that? Because you have like one side and then you have like the other side.
I have a picture coming up of like where the sun doesn't set. You see it go across it and it gets low, okay, but it never sets, it goes back up again. So what's this season then? We're leaving summer. Yeah, it's fall, exactly. It's fall, and this is winter. Okay, and then what's this season? Spring, exactly. So you've heard of the spring equinox, okay? And I've heard it called the fall or the autumnal equinox. Okay, these are 6 months apart. Okay, here's fall and here's spring. The reason the equinox actually the way it works as the Earth spins, at all latitudes you got 12 hours. 12 hours, 12 hours. 12 hours of light, 12 hours of night. At all latitudes, and regardless of the poles, equator 12 and 12. Night and day. Equinox, that's how it came from. Okay. And then actually, as we go ahead and go from spring into summer, our days get longer, their days get shorter. Okay. And then as we go from our summer into our fall, our days are getting shorter, their days are getting longer. Okay. Then as we go from fall into winter, our days are really short. No daylight hours, and their days are long. Okay. So that's kind of how that works. Tilted axis of rotation. And it's kind of fun because you're like, all right, tilt is good. I like seasons. You're going to planet with no seasons, right? But how did it get tilted? And as we start to kind of talk about the formation of our system of the sun, our star, and the planets, actually we think it was really chaotic early on. And Earth was minding its own business getting formed, and it got hit by an object about the size of Mars, sometimes called Theia. Theia? I think so. And it, instead of going like this, it got hit, and it's been like that ever since. Isn't that cool? Yeah.
So how do we know it's tilted then? I mean, how about if it was just actually only like this and still spinning in there?
If it was like this, we wouldn't have seasons. That's one way, yeah. And kind of like what you're saying is they can get angles of the sun to understand what the tilt is. So that's a good question.
It's all very
It's what? So I've got some videos on this, so you might want to check out the videos. But I mentioned, when we're over here, sometimes, and I think it's okay, sometimes students will say, you guys correctly told me that that's summertime in the northern hemisphere. But you're like, it's summertime because we're closer to the sun. And we are kind of tilted, but we're not that much closer to the sun. Our tilt actually gives us more direct sunlight rays. Okay, down here in the southern hemisphere, if you look at the angle of the sun rays that are reaching the Earth, they're very skewed, less direct. Okay. Okay. So I put together this slide to kind of help us all out. You guys told me the 4 seasons grade up here as the Earth goes around the sun. But I'm hoping that you can kind of answer some kind of straightforward questions like this. Like, the 2 hemispheres are opposite, right? So when we have summer, they have winter, okay, and vice versa. So just in the northern hemisphere, our 2 solstices fall kind of, I never remember if it's the 21st or the 22nd or the 23rd. So I just put December 21st or 22nd or 23rd. In December, we are right here, right? It's called a winter solstice, okay? 6 months later, we are right here, June 21st, 22nd-ish. And then we have 2 equinoxes. But just to kind of emphasize, let's see, where are we? This position right here, to emphasize this, it says that if you are north of that line of latitude, 66 1/3 degrees north latitude, then the sun will never rise. Hello? That's bad, okay?
Contrary, or just opposite of that, if you're in the southern hemisphere, that cool Antarctic circle, as the Earth spins, the sun never sets. The sun never rises up north, the sun never sets down south. Okay. And then 6 months later, we switch the north and the southern hemisphere. And then we have the equinoxes. Okay. They happen in March and September. We're coming up on one, right? Have you ever heard the thing balancing a broom, or balancing an egg on a broom, or I don't know.
It's like balancing like an egg instead of on the bottom part, it's on like the top part.
Have you done that before? Have you?
Yeah, it really works. You can stand a broom up too.
Gosh, I've heard that. And it's on the equinoxes.
We did it last year. My kids thought it was like the coolest stuff ever.
We'll keep that stuff going.
You can stand a broom up, or you can stand an egg up, like just on an oval during the equinox. You can stand it up like an egg on a table, and it just actually stands up, or the broom stands directly up and won't fall.
I've heard people say they can do it, and then I've heard others say, no, there's nothing to it. So
You can. I've done that.
that's neat.
I've done both of them.
Yeah, that's cool. Okay, so I said that there's a slide. This is the slide I was talking about. The sun never sets. So at noontime, regardless of, is the sun getting lower in the sky now, isn't it? I mean, even at noon, it's not as high. Yeah. So even so, the highest point of the sun in the sky is going to be your noon. Okay. So along the bottom there, we have kind of some different times. Okay, same location. So this is noon. Okay, 6 p.m. the sun's getting lower. Okay, midnight the sun is the lowest in the sky. It's going to be, oh my gosh. Talk about sleep issues, you know. Man, that just cannot be good. Okay, so yeah, if you're in Alaska, that sort of thing, that would fall into this category of the closer you get to the summer solstice, the more likely you are for the sun not to set. So, road trip. Okay, so I mentioned that it seems like, you know, our sun is getting is now we're going from our summer solstice into our fall equinox, and the sun's getting lower and lower in the sky at noon. And that's actually kind of what this is showing you. Okay, so this would be at the summer solstice. This would be at the winter solstice. Okay, and you know how the sun's position. And I don't know if you're like me, but it kind of feels like fall, you know, and it feels like fall because school started back again. But I think it partly feels like fall because our sunlight is different. The nature of our sunlight is a little bit different. When the sun's lower on the horizon, the Earth's atmosphere kind of filters out some of those blues, and so even at times of day when we were used to getting all colors of light, now we're kind of getting some filtered light. That's my thought on it anyway. So this is my thing about. Remember I said that that it's the tilt that gives us our seasons. We have different hours of daylight. Okay. In the hemispheres, depending upon the Earth's position and because the Earth's axis is tilted, and the directness of the sunlight is different. But this little bit of difference doesn't make a difference. Okay. Now the sun is. There are times when the distance between the sun and the Earth is different. Definitely. We're going to talk about planets that orbit the sun, and we're going to see that they don't orbit in a circle. So since it's not a circle, it's an oval, there are times when we're close to the sun, and sometimes we're farther from the sun. Okay? And I'm going to go ahead and write on the slide terms for the close part and terms for the farthest part from the sun. And I think there's going to be, we'll cover it later too. But let's just say, to me, this, and I'm pretty sure, this distance right here actually is when it's, let me get this right. I know in the dead of winter, about January 3rd, we are actually closest. So I'm going to go ahead and put that over here. So over here, oops, I don't know what to do.
over here, January 3rd, we are closest. And when I say closest, I mean the Earth is literally closest to the Sun. And we call that perihelion. Perihelion. And it is about January 3rd. Okay, so I don't know about, I think we would all agree that January 3rd tends to be kind of cold in our hemisphere. Warm in the southern hemisphere, but cold in the northern hemisphere. Okay, so right away, you know, it's not the distance thing. The opposite of perihelion is called aphelion, and it happens about, I think it's July 3rd. Okay, so it's the farthest, the distance between the Earth and the Sun, and they call that aphelion, A-P-H-E-L-I-O-N. That's an E there between the H and the...
For the perihelion, is it supposed to be H-E-L-I-M, or is it supposed to be something?
H-E-L-I, there's an O there. Yeah. Helion. L-I-O-N. Okay. Another topic I wanted to cover, and I'm going to bring up a little animation to show you, is this idea that, what's that star? Polaris, very good. See, the thing about Polaris, even though we think Polaris is very special now, and it is, okay, but this hasn't always been the case where our North Pole points to Polaris. There's this thing called precession where the Earth has kept its tilt, okay, but it has pointed to a different pole star, or in a different region of the sky. There doesn't have to be a star there for it to work. So when I kind of did this, you're like, oh my gosh, that looks chaotic, right? Okay, but it takes a long time for it to complete one cycle like that. And it keeps its tilt, so we keep having seasons. Okay, so it's come back around in the course of 26,000 years. But as its tilt changes, then that means that as it orbits the Sun, the seasons will change. Have you ever heard of precession of the equinoxes? Okay, they will move, or they have moved over the course of lots of years. So there's a very pretty star, and actually we named it, called it out by name when we were talking about the summer triangle called Vega. Vega is in the constellation Lyra, and at one time Vega actually was a pole star. So next time we're out, we should kind of compare the North Star right now. Polaris is its proper name. And we should find Vega, and we should think, wow, that's crazy. Okay? This was, I thought this kind of did a good job. So it's fast forwarding, you know, we're way beyond the 2014. There's all sorts of conservations of energy, conservations of spinning, conservations of rotation, conservations of linear motion. So that is taken into consideration with this coning movement. So there you go. Something to look forward to. I know. Called precession. Okay. Well, the last two topics we need to cover are about the phases of the moon, you know, a full moon, a quarter moon, a new moon, okay? The phases of the moon and eclipses. So two great topics. So let's see. As we do this, I'm going to kind of, so I have more room up here, I'm going to move the sun. It can still be a trash can. Let's see. Yeah, this will work. Okay, this is going to be the Earth. And I have an Earth here, but I'd like it to be the moon. Can you handle that? I don't know. Is that gonna be confusing? So let's just test us. What's this? Earth, very good. What's this? Still the sun. What's this? Moon, very good. Thanks. Good. Okay, so the deal with the moon is it has no nuclear fusion going on in its core like stars do, so it doesn't shine on its own. The only reason it doesn't glow, if the sun were to go away, it'd be just a rock out there. We like bump into it accidentally. Okay, so, but can you see, for instance, we're going to talk about phases, and can you see if this is the moon, this is the sun. The only reason we see the moon is because of the sun. But which part of the moon's getting lit up? This part over here. So part of it's lit all the time. Can we see that part? You can when you're sitting here because you're outside of the Earth, Moon, Sun system. But if you were on the Earth, could you see this lit up part? Tyree's like, no, but I'm not convinced.
I don't know. Convince me.
Okay, let's do it another way. Okay, we're moon, right? The moon, guess which direction it goes around the Earth?
Counterclockwise.
Counterclockwise. And we're going to see that actually it spins on the axis of rotation counterclockwise too. Okay, so it's going to take the moon a lunar month to go to do this once. Okay, so this is the moon doing its thing. Okay, over here again, lit up, dark. We can't see the moon. Let's go over here, exaggerated halfway through the cycle. Okay, where's the lit up part? Right here. Okay. And the not lit up part is over here. Can we see the moon now? And it's a complete circle, full moon. Okay. Over here, what I was showing you is actually what we call new moon. You can't see it. Remember the other day, some of us started our moon journals, our moon logs, and we're like, I can't find the moon. It's because it was here. Sorry. Okay. Okay, so it says 29 and a half days to do one of these, but what works really well for me is actually kind of bump that down to 28 days, and you're going to see why. Because I like to take its cycle and make it into 4 chunks. And the number 28 is really good to divide into 4 chunks. So 28 days divided by 4 is, how many days? 7. So I love it. So this is new moon, cannot see it at all. Okay, this actually is going to be our first quarter. All right, where is the lit up part? Still, the sun, I know it's not, the trash can doesn't quite work. It's clear out there. So the lit up part is right here. Okay, if you are on Earth looking at the lit up part, can you see where you see dark over here and light over here? So you see basically the disk of the moon split in half, light and dark. Over here you see the full disk of the moon. Okay, now I'm going to go over here. It's going to be about a week. I love it. A week, okay, a week to get there, a week to get here, a week to get here. Okay, so this works pretty good. I'll take this little gray, this will be like my boundary. This will be like my boundary of the sun shining on the moon. Okay, only half the moon gets lit. Okay, this half's getting lit. Now you're right here, you're on Earth. Can you see where you end up seeing this side is lit up? It's like another circle with a lit up half and a dark half. Okay, 1 week later, can't see it at all. Why? Because it's being lit up, but that's the side that you can't see. Okay. So there's a term I want to be able to throw out there if you're not familiar with it yet. It's called the terminator. So actually, if I go over here, okay, this was the deal where you actually see you see a full circle, the moon, but you see a lit up side and a side that's not lit up, right? This right here, where it divides the lit from this not lit up, is called the terminator. And tomorrow night, is that tomorrow? Yeah. We're going to really kind of, I might even give you guys the controls while you're looking through the telescope to kind of move around a little bit. And what you're going to see, the cool part is on the terminator, because actually you can kind of see some ridges and shadows, and it's very pretty. Okay, so Terminator. I'll be back. So all of that I did, I think this gal does a very good job. We'll kind of just, I'll reveal different parts of this figure. So she's the Earth, okay, and you see that orb going around her is the moon that's orbiting the Earth. And the sun's not going to move, it's stuck, okay, for this figure to work. So can you see where kind of drawn in the forced off counterclockwise, right? See the moon orbiting her counterclockwise. And then you see each time, at each moon's position, you see half of the moon lit up. Okay, so here we go. So in this first position, can you see where it was just like I was right here? The fact that the white part, the illuminated part of the moon, it's being illuminated, but she can't see any of it. So in the sky, she sees nothing. So I'll put up these next two. So I kind of went 1 week right to this position. I told you it was a quarter. It is a quarter. It's the first quarter when I was right here. It took about a week to do the new moon to first quarter. In between is what we call a crescent. Anything where you look up at the disk and the disk is less than half, okay, less than a quarter, we call that a gibbous. So I have a slide to kind of summarize these terms. Is that gibbous? Oh, darn it, crescent. Okay, we call that a crescent. Sometimes people call it like a thumbnail. Crescent moon, sorry. And it's less than a quarter. The other term, and I covered it up, but you see the term waxing if it's getting bigger. Okay, so she's right here. The other thing, or there's all sorts of things, but can you see what angle is that? Between the sun, the earth, and the moon.
Right angle.
Right angle, exactly. Our quarters occur at right angles. So I'll go ahead and show you the next two. Okay, so that would be going like this, on its way to full. Okay, it takes about a week to go from that 90-degree angle, that first quarter, to full moon. So notice then, now we use the term gibbous because it's bigger than a bread box. No, it's bigger than a quarter, and we continue to use the word waxing because it's getting bigger. Okay. A week later, she's over, the moon is over here. Okay, and this is our last quarter, sometimes called third quarter. I can never remember if it's third quarter or fourth quarter, so I just say last quarter. Okay. And then last but not least, one little thumbnail then from the last quarter on its way to new moon. Again, we call those crescents. They look kind of like crescent rolls or crescent cookies. Okay. Any questions? So here's the deal. Can you see where, I don't know if this will work for you, but I'm the moon. Okay, I'm orbiting the Earth, and there's the sun over there. For instance, if I am, you can see that the third quarter up here. Can you see where, as the Earth spins on its axis, so we finally get nighttime, can you see where this moon, this third quarter moon, actually, you see what time it rises? It doesn't rise until midnight. Okay? Why? Because as the Earth spins, it has nighttime over there. It has nighttime as it transitions, and it has to swing around until it can finally start to see the moon rise. Okay, so that's why I kind of gave you those hints to where to look, what time of night to look for the moon. Okay, let's see. All right. So I'm not sure if you have access to these or not. These are just some animations, kind of trying to make it a little more real for you. So this is the slide I put together that has the phases that you need to be familiar with. So on your unit exam, sometimes I will kind of ask, can you identify the order of these phases of the moon? Okay? So you might want to throw them on your note card so you don't have to think too hard for your test. Okay, but we have then we have a waxing crescent, first quarter, waxing gibbous, full moon. And then we go from full back towards new. Okay, and since the full is as big as it gets and it's getting less and less, we use the term waning. So first it's a full, then a waning gibbous, then a third or last quarter, then a waning crescent, and then new. It's all right? Things to ponder. Sometimes I'll tell students that if you can kind of lay the terminator kind of as much as possible straight up and down, whatever's happening on the right goes to the left. Okay, so whatever's happening on the right goes to the left. So in this case, can you see the waxing? What's happening is is it's getting more and more illuminated. After a full moon, it's going to get smaller and smaller. So kind of from right to left, what's happening is that dark part is taking over. So speaking of the dark part, one other thing, it's coming up, I need to talk about. Before I talk about that, let me warn you that as the moon, which is the tiny dot up there, orbits the Earth, it's not a circle either. It's kind of off-center. So there are times when the moon is closer to the Earth, and we call that perigee. Where have you heard PER recently? Perihelion, yeah, same thing. Perigee is when the moon is closest to the Earth. Perihelion is when any planet, including the Earth, is closest to the sun. So they got the peri thing going on. Perihelion, okay, close. And then instead of aphelion, it's apogee. Did I say perigee? Have you ever heard of a supermoon? And I think we've got one more coming up in September. Supermoon. So basically a supermoon is when it's a full moon and the moon just happens to be at its closest position, or really pretty darn close anyway to the Earth. Those two things coincide. So supermoon is perigee plus full. Whew. That's it. Not too complicated. Okay, so we have just a few more minutes. No, we're not gonna. Apogee is when it's farthest away, yes.
My kids actually have a nightlight that's the moon. That's a remote that sits there and goes through the phases.
Oh, that's cool. Your kids are awesome. They got an awesome mother, so.
Their grandma got it for them. It's by Discovery Kids. It's really neat.
Oh, cool. Well, let's hold that last topic. I like this next topic about the whole far side and near side of the moon. We're going to hold that topic and eclipses for Friday. So the homework's not going to be due until Monday, if that works for you guys. And then also, we'll start chapter 3 on Friday. And hopefully we'll have a lab in between then.